Okay, AWS Fargate increases compute and memory resource configurations by 4x.
Yeah.
Okay,
so this basically allows you to run really large containers in a completely serverless model. And you don't have to worry about anything, including scaling or capacity, any of that stuff. And the fact that these containers are now going to be 16 vCPUs and 120 gigs of RAM, that's plenty to run most workloads. That's really a lot to run.
And 120 gigs of RAM, which is also 4x. This is great.
So, I mean, it just makes the case for serverless so much stronger, right? I mean, what workload would not fit on a 16 vCPU instance and, scale infinitely and, have 120 gigs of RAM? Like that the set of workloads that meet that criteria is just shrinking dramatically.
It's really neat to think about how more and more, let's say, the amount of resources that can be immediately marshaled in a serverless way, right?
Yeah.
Like when Lambdas came out, it was very, very, very lightweight, and now you can have Lambda with 10 gigabytes of instant storage.
Correct.
That you can have, in a few milliseconds notice.
Exactly.
Now with this thing, with Fargate, to be able to have 120 gigabytes of memory accessible in a serverless way, you're right. That's a big deal.
Yeah, that's a really big deal. And for me, the difference, the more I think about it, Lambda started at one end of the spectrum and Fargate started at the other end of the spectrum with containers. But when I start seeing the features that are being added to both, I feel like they're both moving closer and closer together, and it might just end up overlapping a lot. Like if you really think about, you can
start on
AWS.
AWS. There might be more than one way to do something.
Yeah, I mean, think about it. The amount of compute memory and stuff that's being added to Lambdas, and the fact that they can now run for 15 minutes at a time, makes a huge difference. There was a time when Lambdas would not run for more than a minute. Then they increased that to 3 minutes, then 5 minutes, and so on. And the only opportunity, or the only option rather, to run a long-running job. And I said long-running is relatively long-running. Even 5 minutes would have been long-running from a early Lambda standpoint. Today, a long-running job would be anything in excess of 15 minutes. If you were running a job like that, then Fargate is your choice. But I wouldn't be surprised if Lambda then now goes to 30 minutes and they have another way of doing it. The other thing that kind of blurred the separation was that pretty much both on Fargate and on Lambdas, you can basically package up your entire code as a container and deploy it on either one of those two services. So there's really no distinction that I see in terms of the way you package up your code, write your code or whatever. It's just you make a judgment call on whether something is long running or not and decide where to host it. That's fundamentally the difference. And now 15 minutes, 30 minutes, I mean, most jobs should not take that long. So the thing is blurring a lot for me, the distinction.
So that will be interesting if in the future we do have, like you said, 30 minutes or 1 hour or arbitrarily long Lambda functions, and how the availability of those changes how we use them.
Yeah. I couldn't agree more. So the only thing that I feel is between Lambda and Fargate, I think it makes decisions a lot harder for the end user. Like, how do you decide when to use Lambda and when to use Fargate?
That is
I would use one of those two for sure, but when do you use which?
So that's an interesting question. Well, let's see. Well, anything else that comes up on this article? Let's see. I like that it supports x86 and ARM.
I think there's one other thing that I wanted to bring up, which is I think I saw another article that talked about, an announcement about ECS in
This one.
comparison. Yep. Well, this might seem really neat. With everything that's going on with Fargate and stuff, this kind of an announcement just brings to question as to why you would want to manage all of this stuff yourself. Like, why would you want to manage an entire cluster and a fleet and figure out how to auto scale it quickly, figure out, warm up times, figure out how much, figure out how to keep your images cached if you have heterogeneous workloads, because just loading up all these images on a new node takes its own sweet time. When a node goes down, if you have heterogeneous workloads on it, you lose a lot of images that are stored locally. How do you bring that all back? So if there's a cold start time associated with those, and auto scaling, then you have to manage your auto scaling groups, figure out how they will scale, when they will scale, figuring out all the rules and events that drive that. It's just too much overhead. I just don't know why.
No, I can feel my heart rate raising of thinking about, okay, scaling to 1,000, scaling back to 100, doing all I've done that kind of stuff manually before, and it's unnerving having to do all this stuff. And maybe some institutions or users really like the control, I suppose. But I guess often you find that control doesn't buy you as much as you think it does, and it's a lot more expensive than you think it is.
It's way more expensive for sure to have to do this all yourself, because then the cost of a mistake is way higher than you'd ever imagine. Right?
Yeah.
And if you are managing all of this stuff and that becomes your primary job, it's hard to do it. You'd much rather let someone like AWS do it, where they are managing a serverless service. The SLAs are very crisp, very clear. And in a lot of these things, I'm coming to this conclusion that we get taught in tech that don't walk down the beaten path as a slogan that drives almost all of tech, which basically tries to say, hey, innovate, do something new, do something different, don't do something else. But when it comes to infrastructure, when it comes to deploying these things, you want exactly the opposite. Do things that a million other people have done before, so that it is reliable, it is stable. This is the foundation on which you build your tech differentiation. That foundation has to be absolutely rock solid and tried a million times before.
Yeah, just like, you don't want your plumber to look at your pipes and say, "Wow, I've never seen anyone else do it this way before." You want them to say, "Okay, yeah, this is exactly the same as everyone else does."
That is, I think, the best way to kind of, explain this to somebody. I'm just visualizing the shock on my plumber's face if he saw bespoke, bespoke plumbing that he doesn't have any clue about how it operates.
And you were going to get a bespoke bill at the end of that process. Oh, actually, that's actually a great plug for. Well, I guess it reminds me of the talk that you gave a few weeks ago at the Partner Summit about bespoke problems have bespoke costs, or bespoke code has bespoke costs to maintain.
Correct. Now, I think that goes with every aspect of our software development lifecycle. I think the only thing that needs to be bespoke is the idea.
Yeah.
Beyond that idea, everything else should be something that you can, pick off the shelf, something that everyone understands, something that's easy to manage, easy to maintain, and most importantly, easy to replace. If it is not easy to replace, you're going to live with it forever, and it's got to go with you to your grave. It's that bad. So you have to design things that are easy to delete, easy to replace.
Yeah, and you're right. Often the core idea is so small, right? And everything else is getting the data to there, serving the data, validating if an email address is a valid email address, all that stuff, right? It's been done 1,000 times before, and much better to get someone else to do it.
Exactly. And there is no technical differentiation in that work. It's commodity at this point. When 1 million people have done things a certain way, tag it as commodity. And if something is commodity, you have to figure out how to leverage it. Don't go build another custom solution around it.
And also thinking about even that example of an email address, right? There's email addresses can be more and more and more complicated, right? It's easy to think, okay, I could write a regular expression to validate an email address, and I don't want to pull in some library. No way. Email addresses there's 1,000 edge cases that have been well trotted out. Same with anytime you handle strings.
Exactly.
There's this great GitHub repository. I think it's like the list of very bad strings. And it's something that anytime you deal with strings, you say, okay, there it is. I'll put it in the chat. It's the big list of naughty strings. And these are all strings that are valid, that if you want to handle a string, you should be able to deal with. Right? You want to use someone else, like unless your core business is handling strings, you want to let someone else do with this.
Completely agree. And yeah, so I think we kind of overdo the custom, it's not built here kind of syndrome. We see too much of that in tech, and we kind of need to change our attitude towards that.
And I think that there's room for it, but it's just maybe not in production code, right? It's for things that are meant to be works of art.
Yeah, and
like
there are some things that are going to be unique, but that's got to be a core value differentiator, a core value proposition. Okay, and 90% of your code base can't be that.
Yeah. Well, it looks like we're hitting 10 o'clock Pacific time. I think you're at 9:30 p.m. Wow. Well, next week we're going to have our behind the scenes part 2. We're going to see what we can do about the indexing all the Amazon articles we've already talked about, show you some fun with recognition. Hopefully we can find that custom entity recognition model, and be able to tag all of our transcripts with what AWS services we talked about, and see how we can tie that all together. So looking forward to behind the scenes part 2 next week. Thanks, Rahul. It's been a really good episode. And thank you, audience, for joining in. We will see you next week.
Thanks, everyone. And let us know what else you would like us to talk about on this show. Looking forward to it.
Well, have a good afternoon, evening. Bye-bye.
Bye-bye.
Is your AWS public cloud bill growing? While most solutions focus on visibility, CloudFix saves you 10 to 20% on your AWS bill by finding and implementing AWS recommended fixes that are 100% safe. There's zero downtime and zero degradation in performance. We've helped organizations save millions of dollars across tens of thousands of AWS instances. Interested in seeing how much money you can save? Visit cloudfix.com to schedule a free assessment and see your yearly savings.